Welcome to the final case in this series, and it is unlike every case before it because it has not happened. This is a structured thought experiment, a day in the aviation system of 2035. Let me be precise about its status, because the slide insists on it. This is not a prediction, it is a stress test. We are not claiming to know what 2035 will look like. We are constructing a plausible, demanding scenario and asking a disciplined question. What human factors capabilities will that system actually demand of the people inside it? Every framework this book has taught, Swiss cheese, barrier analysis, the investigation lenses, mixed methods evidence, is about to be tested against a system we have not yet built. Picture the scenario: a major hub and every mode of flight operating at once, long haul and short haul, regional turboprops, hydrogen-powered aircraft, electric trainers in the circuit, and eVTOL air taxis threading between vertiports. Second, AI is everywhere. Dispatchers optimizing with machine learning tools, controllers supported by conflict prediction systems, engineers on predictive maintenance dashboards, regulators watching AI-driven risk pictures. Third, an EMCO trial is running. Reduced crew crews under staged evaluation on selected long-haul routes, the live edge of the Germanwings paradox we examined earlier. And fourth, this is essential to the design of the thought experiment. It all works. On a normal day, the system performs with an efficiency that would astonish us today. The point of the scenario is not that the future fails, it is what happens next. Then disruption arrives. And notice that it arrives the way disruption actually does, from several directions at once. A convective system develops faster than the weather models forecast. Vertiports hit their wind shear limits and close, dumping eVTOL traffic back into the system. A cybersecurity alert flags a possibly compromised data feed. And on the control floor, the AI conflict prediction tools begin issuing alerts that contradict what controllers can see with their own eyes. Every AI tool in the building is suddenly operating near, or past, the edge of what it was trained on. And here is the sentence the entire chapter pivots on. When the automation reaches its limits all at once, the safety of the whole system falls back on the humans in it. The question is whether we will have designed and trained for that moment. Pressure 1. Convergence. The scenario's stressors do not arrive politely, in sequence. Weather, vertiport closures, the cyber alert, and a capacity cut land together. Individually, each is manageable. The system has procedures for all of them. What it may not have is the capacity to absorb them simultaneously. And the second point compounds the first. The 2035 system is tightly coupled. A single degraded data feed does not stay local. It ripples through dispatch optimization, ATC conflict prediction, and airport flow management at the same moment because they all drink from the same data. Those of you who know Pero will recognize the signature: interactive complexity plus tight coupling. We are building a system with more of both, and convergence is its characteristic failure mode. Pressure 2. Supervision by exception. In 2035, controllers and dispatchers no longer perform most tasks. They supervise fleets of AI agents that do, intervening only when something is wrong. This is a fundamentally different cognitive job, and a harder one. It demands calibrated trust, enough confidence to delegate, enough skepticism to override, sustained across long periods when the automation is nearly always right, and the scenario engineers the exact moment that tests it. A conflict alert that contradicts what the controller's own eyes tell them. Which do you believe? The system trained on millions of cases, or your direct perception right now, in conditions the system may never have seen? That contradiction is precisely where human judgment must step in, and precisely what decades of automation complacency research warns us humans are worst prepared for. Supervision by exception only works if the exception can actually be recognized, understood, and acted on. Pressure 3. The human margin, where resilience actually lives. 2 vignettes from the scenario. A hydrogen-powered aircraft is holding, and its crew must manage fuel reserves under a technology with no deep historical precedent. No fleet memory, no folklore, no "we've seen this before." They are, in the truest sense, beyond the training envelope, and what carries them is fundamental understanding and disciplined improvisation. Meanwhile, a regulator watching the national risk picture cannot tell whether an anomaly is a genuine emerging risk or an artifact of the compromised data feed, and must decide anyway under time pressure with irreducible ambiguity. Notice what both vignettes share. The automation has nothing more to offer. What remains is judgment. That residue, human performance precisely where the envelope of the designed and trained ends, is what this book has meant by resilience all along. The deeper mechanism and the thesis of the entire final chapter, the safety isn't in the technology. On the normal day, it looks as though the technology is doing the safety work, and mostly it is. But when every automated tool reaches its limit together, what holds the system is the adaptive capacity of the people inside it, the ability to recognize the novel, to question the automation, and to improvise a safe path where no procedure exists. That leads directly to the design imperative on the right of the slide, design for the edge. The 2035 system must be built so that humans can still understand, question, and override AI precisely when it is operating past its envelope, which means transparency about confidence and limits, interfaces that support doubt, authority structures that make the human override real rather than theoretical, and training that rehearses the edge, not just the routine. 3 lessons that close not just this case but the series. First, enable, don't just correct. Human factors began as the discipline that explained failures after the fact. Its future is upstream, embedded in the design of systems, so it prevents the failure it would otherwise have to explain. Second, keep the human able to intervene. Supervision by exception is only a safety architecture if the people at the top of it genuinely understand the systems they oversee and hold real, practiced, exercisable override authority. Automation that cannot be questioned is not a safeguard. It is a single point of failure with excellent uptime. Third, invest in adaptive capacity. Train for the novel and the ambiguous, because the routine will be automated, and the edge is where the automation ends and human resilience begins. That is where safety will live in 2035, exactly as it lives there today. To close the series, this scenario is the concluding case of Chapter 15, Emerging Challenges and Future Directions, and deliberately, the closing argument of the book. Every framework the preceding chapters developed is tested here against the system we are about to build. The latent conditions of Überlingen, the threat models of Germanwings, the analytical lenses of AF447, and the evidence-building discipline of the SIPO study all reappear in the 2035 operation. The full treatment is in Aviation Human Factors, Theory, Research and Applications for Advanced Aviation Systems, Ziakas and Peklavanis, CRC Press, 2026. Thank you for following the series. The future system will be safe only if we design the human into it from the start.